In July 1943, Germany unleashed what was meant to be its war-winning tank, only to see 160 Panthers lost in 48 hours, most without even meeting the enemy. This wasn't a battlefield failure, but a disaster engineered years before the first shot was fired. A single October 1941 ambush exposed the Wehrmacht's weakness and sparked an arms race that the Panther was supposed to win. So why did the most advanced tank miss its own war? The answer begins with the shock at Mtsensk, when defeat forced Germany to gamble everything on a promise of perfection. October 1941. The forests and fields near Mtsensk churn with mud, smoke, and the sound of engines. Colonel Mikhail Katakov's 4th Tank Brigade, with just 60 T-34s, faces off against the full weight of Heinz Guderian's 2nd Panzer Group, hundreds of German tanks and armored vehicles pressing hard toward Moscow. The Germans expect another quick victory. Instead, they run into steel and determination. Katakov's crews use the terrain, hiding their T-34s in the woods and waiting for the right moment. When the Germans advance, the Soviet tanks strike from close range, shells ricocheting off the T-34's sloped armor. German 37mm and 50mm guns, so effective elsewhere, can barely scratch the Soviet tanks from the front. Only a lucky shot at the rear or sides stands a chance. For 9 days, the German spearhead stalls. Guderian's advance grinds to a halt. Soviet records claim 133 German tanks destroyed at the cost of 28 T-34s lost. The German combat logs reflect the frustration. Their best units are stuck, unable to move forward, forced to call in airstrikes and artillery to break the deadlock. The T-34s, with their wide tracks and diesel engines, move easily through mud that bogs down the German panzers. German crews watch as their shells bounce off the enemy's armor, while the Soviet 76mm guns punch through German tanks at a distance. What was meant to be a swift breakthrough turns into a costly standstill. The 9-day delay at Mtsensk is not just a battlefield setback, it becomes a warning. The myth of German armored invincibility breaks down in the mud and smoke, replaced by a new fear: the enemy has a tank that outmatches anything the Wehrmacht can field. Guderian's officers, stunned by the losses, demand answers. The message is clear: if Germany wants to regain the initiative, it needs a new tank. The urgency for technical analysis and innovation is set in motion, driven not by victory, but by the shock of defeat. German teams moved quickly to inspect the wrecked T-34 tanks left behind at Mtsensk. What they found was unlike anything in their own arsenal. The T-34's armor, sloped at 60 degrees, gave 60mm of steel the stopping power of much thicker plate. Its 500mm wide tracks let it glide over mud and snow where German tanks bogged down. The Diesel Phi-2 engine ran cooler and was less likely to catch fire, while the 76mm gun could destroy both tanks and dug-in infantry. One frontline report captured the mood: "Give us this tank." But imitation proved impossible. German metallurgists faced a hard limit. Their steel lacked the molybdenum and vanadium alloys that gave Soviet armor its strength. Aluminum, essential for building lightweight diesel engines at scale, was already earmarked for the Luftwaffe. German factories could not produce a clone of the T-34, even if they wanted to. The diesel debate grew heated. Diesel engines ran safer, but Germany's industrial base was locked into gasoline technology. The Maybach engines they relied on were powerful, but also thirsty and prone to overheating when pushed beyond their original design. Cultural barriers ran just as deep as material ones. German engineers bristled at the idea of copying a Soviet design outright. There was a belief, unwritten but powerful, that German tanks must be more than just functional. They had to be superior, both in engineering and in battlefield performance. The result was a decision not to copy, but to compete. Design teams were ordered to create something that would outclass the T-34, not merely match it. The stage was set for a contest of philosophies, simplicity and ruggedness on one side, complexity and ambition on the other. The technical gap was clear, but the path forward would not be a straight line. Instead of a direct imitation, Germany would pursue a new tank that could reclaim the initiative, one that would bear the scars of every compromise and every ambition built into its steel. In the spring of 1942, two visions for Germany's next tank stood in sharp contrast. Daimler-Benz offered a design that borrowed heavily from the Soviet T-34. Their proposal featured a diesel engine, rear drive, wide tracks, and a low silhouette, an attempt to capture the T-34's rugged reliability. Simplicity defined every line and component. The hull was boxy, the suspension used leaf springs, and the build prioritized ease of production and field repair. Daimler-Benz engineers argued that this was the fastest way to put a new, effective tank into German hands. Their plan called for a 35-ton machine, armed with a long-barreled 75mm gun and protected by sloped armor. The diesel engine would have reduced the risk of fire and offered better fuel efficiency, while the rear drive matched the T-34's proven mobility across mud and snow. Facing them was the MAN team, led by a different philosophy. Their design kept the gasoline Maybach engine, but placed the drive sprocket at the front. The MAN tank used a torsion bar suspension with interleaved road wheels, a signature of German engineering, promising a smoother ride and better cross-country speed. The turret and hull shape were more angular, and the entire machine was laced with technical complexity. The MAN proposal aimed for superior optics, radios, and a high-velocity 75mm gun. But every innovation added weight, maintenance demands, and production delays. The initial specification called for 35 tons, but the design was already pushing those limits. On paper, both tanks offered a leap beyond existing German models. But the choice was never just about the technical merits. Inside the Waffenamt Armored Vehicle Department, Heinrich Kniepkamp's influence was decisive. As chief of Waproof 6, Kniepkamp championed the torsion bar suspension, a feature he had promoted since his work on earlier German tanks. He argued that this system, though more complex, would give German armor an edge in mobility and firepower. The MAN proposal fit his vision, and his connections with the MAN firm gave their design an inside track. The official rationale for rejecting Daimler-Benz's design was its resemblance to the T-34. There were concerns that German troops might mistake it for a Soviet tank in the chaos of battle. But internal records and engineers' memoirs tell a different story. The real reason lay in the desire to outdo the Soviets, not imitate them. German engineering culture demanded originality and technical superiority. Kniepkamp and his circle saw the MAN design as the only acceptable path, even as others warned that its complexity would slow production and strain field maintenance. By May 1942, the decision was made. MAN's design advanced to prototype, while the simpler T-34-like tank from Daimler-Benz was set aside. The Panther would be a showcase of German ambition, powerful, innovative, and complicated. The path was set, not by what was easiest to build, but by what promised to be the most advanced. That promise would soon be tested, not in the drawing rooms of Stuttgart or Augsburg, but on the muddy fields of the Eastern Front. The Panther was never supposed to be a 45-ton machine. The original blueprint aimed for 35 tons, enough for a long-barreled 75mm gun, thick sloped armor, and the mobility to match the T-34. But the blueprint did not survive the conference table. In the spring of 1942, as prototypes neared completion, Hitler intervened. He demanded more. The Glacis plate, already formidable at 60mm, was to be increased to 80. The turret face, 80mm, was to climb to 100. Each order added tons to the design, and with every extra centimeter of armor, the Panther grew heavier until it tipped the scales at nearly 45 tons. On paper, the numbers looked reassuring. Thicker armor meant better protection. But the calculations stopped at the armor plate. The Maybach HL-230 engine, rated for 700 horsepower, had been designed for a lighter tank. The transmission, a ZF AK-7-200, was built to handle the original weight. Neither was upgraded to match the new demands. The drive sprockets, final drives, and gearboxes all faced forces they were never intended to bear. Technical memos from the summer of 1942 warned of the risks. Engineers flagged the mismatch between weight and drivetrain, but their cautions were lost amid the pressure to deliver a tank that could dominate the battlefield. The Panther's interleaved suspension, a marvel of German engineering, was also pushed to its limits. The added armor increased the load on each wheel and torsion bar. In muddy or uneven ground, the system strained under the extra mass. Field mechanics soon found that replacing a single damaged wheel could mean unbolting half the suspension, a task that cost precious hours in combat conditions. At the heart of the problem was a contradiction. The Panther was armored like a heavy tank, but powered and geared like a medium. The HL-230 engine ran hot, especially when forced to move the heavier hull. Fuel lines routed close to the engine block became a fire hazard. The transmission, designed for 35 tons, began to fail after just 30 to 50 kilometers of hard driving. Gear teeth stripped, bearings seized, and the final drives cracked under torque. In the rush to meet Hitler's deadlines, these flaws were not fixed in time. Instead, early production models rolled out with all the vulnerabilities baked in. Hitler's handwritten notes from May 1942, insisting on thicker armor, are preserved in the archives. They reveal a leader convinced that more steel meant more survival. But behind the armor, the Panther's hidden fragility was set. Every extra ton, every millimeter of plate became a liability waiting to be exposed not by enemy fire, but by the demands of its own design. The tank that was meant to be a wonder weapon was now a balancing act, its strength undermined by the very decisions meant to ensure its victory. Operation Citadel was supposed to be Germany's answer to the T-34. The plan called for a massive armored assault in early May 1943, using new tanks like the Panther to punch through Soviet lines before the Red Army could recover. But the Panthers weren't ready. Production delays, last-minute design changes, and the struggle to fix mechanical flaws forced the German High Command to wait. Citadel was postponed again and again, first to June, then to July. Each delay gave the Soviets something more precious than any weapon: time. Soviet engineers and soldiers worked around the clock through the spring and early summer. By July, the Kursk salient bristled with defenses. Sapper battalions laid down nearly 1 million mines, over 800,000 anti-tank, and 180,000 anti-personnel across the approaches, fields, and likely attack routes. In some sectors, the density reached 5,000 mines per kilometer. Minefields were layered, sometimes 3 or 4 deep, designed to cripple tanks before they could even reach the front line. The earth itself became a barrier. More than 10,000 kilometers of trenches zigzagged across the landscape, dug by soldiers and civilians alike. These were not just shallow ditches. There were deep firing trenches, communication tunnels, and command bunkers, all connected by a network that stretched farther than the distance from Moscow to Paris. Anti-tank ditches, wide enough to swallow a Panther whole, cut through the fields. Wooden and concrete obstacles called dragon teeth rose in rows, forcing tanks into narrow kill zones pre-sighted by Soviet artillery. Behind these obstacles waited thousands of guns. Soviet artillerymen spent weeks registering their fire on every likely avenue of advance. When German tanks finally rolled forward, the gunners needed only to call out coordinates. They already knew the ranges by heart. Machine gunners and anti-tank crews trained on mock-ups of German armor, rehearsing ambushes again and again. Fresh divisions, rested and resupplied, rotated into the line. The Soviet command used the delay to reinforce weak points and build up reserves, ready to counterattack at a moment's notice. By the time the Panthers arrived at the front, the battlefield had changed. What had been open country in the spring was now a fortress. The German timetable, meant to deliver a knockout blow, had instead given the enemy months to prepare. Every day of waiting added another layer of defense, another obstacle for the Panthers to overcome. The ground was ready, not for a breakthrough, but for a grinding, attritional battle where every meter would have to be paid for in blood and steel. 16. Panthers never even reached the front line at Kursk. Their engines seized or caught fire on the march, and they were abandoned before a single shot was fired. As the attack began, 36 more were disabled by mines, steel hulls stranded in fields laced with explosives, crews forced to bail out under artillery fire. Mechanical breakdowns outpaced combat losses. Transmission failures, torn final drives, and engine fires left entire battalions immobilized in the mud. Field repair teams worked around the clock, but the pace of destruction outran their efforts. By the end of the first 48 hours, only 40 Panthers of the original 184 remained operational. For the men inside, the cost was measured in more than lost vehicles. Count Hyacinth von Strachwitz, one of Germany's most decorated tank commanders, was wounded when his Panther broke down under fire. Exposed and unable to move, he was hit by shrapnel, ending his command at the front. Veteran Panzer Grenadier Gunther Böhme, who had survived the brutal campaigns of 1941 and 1942, died in agony when a fuel leak ignited his Panther's engine compartment. The machine's promise of protection became a death trap. These were not green recruits, they were survivors, men whose fate was sealed not by enemy fire, but by the flaws of their own equipment. The Panther's advanced design was never in doubt. Its 75mm KWK-42 L-70 gun could destroy a Soviet T-34 at over 1,500 meters. Sloped 80mm frontal armor made it nearly immune to most Red Army guns at range. At Kursk, Panther units claimed 267 Soviet vehicles destroyed, more than any other German tank unit in the battle. But the numbers tell a different story. Of the 6,500 Panthers built during the war, only a fraction ever reached the front in time to matter. The Soviets produced over 57,000 T-34 tanks, flooding the battlefield with numbers the Germans could never match. Repairs and redesigns did follow. By May 1944, Panther readiness climbed to 78% as field fixes and factory upgrades took hold. Fuel lines were rerouted, transmissions reinforced, and engines improved. Later models proved deadly in skilled hands. Yet the shadow of Kursk lingered. The Panther became a blueprint for the future. Its sloped armor and high-velocity gun inspired the Soviet T-54, the American M48 Patton, and the British Centurion. Museums and test ranges across the world studied its lines and lessons. But for the men who needed it most, the Panther's promise came too late. The war had already passed it by. Perfection delayed the Panther until it was outnumbered 10-1, a lesson modern militaries still risk forgetting. Today, technological ambition often collides with urgent reality, as seen in multi-billion-dollar weapons projects that arrive too late or not at all. The true cost isn't in lost machines, but in lost opportunities, reminding us that in war and beyond, timing is often the ultimate force multiplier. What do you think? Join the conversation below.